All right, how you doing, everybody? We're back at her. Totally different. We're changing gears here. We're not talking about systems of equations anymore. We're getting into the equation of a circle. Now, in grade 10, the center of the circle is at the origin, so right in the middle at the beginning at 0, 0. All right, when you get into grade 11 or 12, you'll look at circles that get moved, shifted around a little bit. Now, the equation of a circle. It looks complicated, but it's not that bad. The equation of a circle is x squared plus y squared. So that's a little bit different in that the x and the y are on the same side here, is equal to r squared. Now, what does that r represent? Well, this is where r is the radius of a circle. All right, now just to draw some parts of our circle, just in case you're a little slipping on grade 9 math. That's not a bad circle for me. Again, the key is we have a center of a circle. Your radius is from the center to the outside of that circle. All right, so that's your r, your radius. We also have other things like the diameter, which is from one side of a circle all the way across to the other, but again, has to go through the middle. That is your d, which I will throw down here as your diameter. All right, so that's your d. Now here's something a little bit different that you wouldn't have done in grade 9, is you also have from one side of a circle to the other, but you don't go through the center. And I'm going to call that C, and that is what we call a chord. All right, now there is a relationship here with the diameter, because it's all the way across the circle, and the radius is only halfway across the circle, is that your diameter is equal to 2 radiuses. So again, that is something hopefully covered in grade 9, but again, I don't know what you did, especially with 2020 and COVID. All right, now, again, here's the equation of our circle. X squared plus y squared equals r squared. And the best part, now it does look funny, but the best part about the equation of a circle is that all you need to know is the radius. You just need to know the distance from the center of the circle to the outside. You square that number, you've got yourself the radius. Now, I could also take the square root of both sides of this equation, and so that this equation could also be x squared plus y squared, and it's square rooted. But if I square root r squared, that gets rid of the little 2, and so that's how we find the radius of a circle. If we know an x and a y value that are on the circle, then we can find our radius. All right, which then leads us to example number 1, where it says graph the circle. So I'm going to use some of this information here. So graph the circle that has the equation x squared plus y squared equals 25. All right, so we're going to graph that circle. And the hardest part is just, well, you have to identify the radius. Now that 25 there is not the radius, it's the radius squared. But what I can do is, because the radius squared is equal to 25, I can square root both sides. And our r value is 5. So I know that from the center of the circle, which for us is going to be the origin here, 0, 0, if I go 5 all the way around the outside, I can graph my circle. And so a sketch of my circle, so I'll just draw a little diagram here. And so again, there's the center of our circle right at the origin. And the easiest way to draw a circle, well, for me anyways, unless you're artistic, is that the radius is going to be 5 directly to the right, 5 directly to the left, so that'd be -5 out here, 5 upwards, what our radius would reach, and 5 downwards. Those are the easiest. Now here comes the hard part, especially if you're artistically challenged like me right here, is drawing it in. So I know that this is a point on the circle, this is a point on the circle, this is a point on the circle, and again, down here is a point on the circle. All right, here we go. I'm going to try to draw my circle. No laughing. I usually like it when I'm on my smartboard because I can just erase it when I mess up the first time. That's not going to happen here. So hopefully this looks like a circle. Here we go. All right. I'll take it. I'll take it. There we go. So there's my circle. A little weak here in the fourth quadrant. I like the rest of it. But again, the key is here, find your radius, and then you can go 5 out, 5 to the right, 5 to the left, 5 up, 5 down, and there I've drawn my circle. All right, now we are going to look at part B. All right, so I guess I'm going to have to do a little erasing here. So again, there's our information. Now, part B asks, are the following points inside or outside the circle? So x squared plus y squared. So we're still dealing with the same circle here. Equals 25. All right. And so the first point I'm looking at to see if it's inside is the point 2, 5. So would that point be inside or outside, or maybe even on the circle? All right. And so here's what happens. Here we have the equation of the circle. We know that the radius, again, you square root 25 is 5. All right. So it has to reach out a length of 5. And so what we can do is I have an x value here. I have a y value here. And I can substitute them into the equation and see what I get and compare it to 25. All right, and so in this case, my x value, again, as I said, is 2. So I'm going to square the 2 because that is in the form of the equation of a circle. I'm also going to square the y. All right, now I want to see what it equals, and I want to compare it to 25. All right, because let's see here. So 2 squared is 4. 5 squared is 25. Now they total up to give you 29. That means this point reaches outside because the number is greater than 25. This point reaches past 25 because it's 29. And the point 2, 5 is then outside the circle. All right, so I plug my x and y values in because I don't know whether it's inside or outside or maybe even on the circle. I found it a total of 29. It is bigger than 25. That's what we're comparing it to. That means it's outside the circle. Another point, -3, 1. Okay, and I'm going to do the same thing I did before. I'm going to plug it into the equation of a circle, which is x squared plus y squared, and see if compared to 25. And so my x value there is -3 squared, all right, plus my y value, which is 1, so I'm going to square it. And once again, now this is something that tricked a few of you up on the test, last test, and I said it over and over again. When you have a negative and you square it, you're going to get a positive answer because a negative times a negative gives you a positive. And so -3 squared, -3 times -3 is 9. Plus 1 squared, 1 times 1 is 1. If I put those two together, I get a total of 10. And so when I compare that to 25, that is way less than 25. And so therefore, the point -3, 1 is inside the circle. In fact, that number will tell you that 10 is much less than 25. It is way inside the circle. This 29 here, yeah, it's probably just outside the circle. All right, and let's try another third point here. I got a 4, -3. And again, I want to see, is this point inside or outside or maybe even on the circle? Okay, so again, I'm going to substitute my x value and my y value into the equation of a circle, all right, to see what the radius is from this particular point. And so my x value is 4, so I'm going to square it. My -3, I'm going to square that too. All right, and so 4 squared is 16. Again, -3 squared, we just had that one, right? -3 times -3, we get a 9. All right, I add those two numbers together. And so I have 16 plus 9 is 25. That is our radius. It reaches, it's right on the circle. So because it is equal to our number, our radius squared, this point, which is 4, -3, is on the circle. And there we go. All right, so that's seeing whether a point, given the equation of a circle, is either on it or outside it or inside it. 3 different scenarios there. All right, let's see. Example number 2. What are we doing here? Example number 2, find the equation. Okay. Eddie. All right, so example number 2 says, find the equation of a circle that again has its center at the origin. And as I mentioned before, all of our circles will have a center at the origin. Okay, and so this point, circle, passes through point, what do we got here? -6, 8. All right, so a little bit of a sketch of what we got going on here. We have a circle. And forgive me for my artistic limitations here. All right, and we have this point -6, 8, which is 6 to the left, 8 up. So I'm going to say it's right in here. Again, it's just a sketch. All right, and what we want to find, or all we need to find, is that radius, right? Because the equation of a circle is x squared plus y squared equals r squared. So here's what we can do to find that r squared. We can substitute in our x number, we can substitute in our y number, and we can find out what r squared is equal. And then we will know the equation of a circle. All right, so I'm going to sub in point -6, 8 to find r squared. All right, and so my x value again is -6, and I square it, plus 8 squared. All right, and let's see here. So -6 squared, again, we have a negative times a negative. So that's going to give us a positive 36. I take 8 and I square it, and I get a 64. And if I add those two numbers together, 36 plus 64, we get 100. All right, so therefore, the equation is x squared plus y squared. And again, all we wanted to know was what is r squared, and when we substitute those x value, the x value and the y value into the equation, we do get the r squared. And so there's the equation of our circle. Now, part B is I could ask, and I didn't in my example here, but what is the radius? Well, if r squared is equal to 100, I could again square root both sides, and the radius of this circle is 10, because the square root of 100 is 10. So the radius is 10. I go out and I meet at the point -6, 8. But there is the equation of the circle. I just have to get the r squared. So you can do that a couple ways. You can either find out what the radius is and then square it, or in this case, we had a point, I substituted in, and I just straight out found r squared. All right, so that's example number 2. Let's see here. Now we get to example number 3. Right, so let's use that. All right, so example number 3 says graph, this is part A, I guess. Graph the circle. I'm just going to write short form here. X squared plus y squared equals 45. All right, so that's the first step. I want to graph that. All right, so again, I know that my r squared is 45. All right, now if I'm going to graph this circle, I need to know the radius. And so, well, to find the radius, I'm going to have to square root both sides here. And so I got to square root 45, and last time I looked, that is not a nice number it's a decimal. So I'm going to square root 45, and I get 6.71. All right, that's the 2 decimal places. All right, and so now if I'm going to graph my circle, I know the radius. And just like I did in that first example, I'm going to go 6.71 to the right, because it's straight away. It's easy to find that out. I'm going to go negative 6.71 down, or 6.71 down. I'm going to go 6.71 to the left, and I'm going to go 6.71 upwards. So there's 4 points. I could use a million points. It's going to be a struggle for me because, again, artistically challenged here. So here we go. I'm going to try to draw my circle. I have a feeling this one's not going to be as good as my first one here. All right. Okay, now I struggled on this 4th quadrant. Let's see if we can pick it up. Surprised myself. That ain't bad. That ain't bad. So again, there we go. I've labeled 4 points. I graphed my circle. All right, and then now we get to part B. And part B says if, let's see, let's go part B. If line segment AB is a chord. So again, a chord means you have 2 points connected on the circle, but they don't go through the center. That's a key there. Let's see here. So if AB is a prove AB is a chord. All right, and that is if, run out of ink here, if point A is, let's see here, what point do I got? Point A is, we got some negative 3.6, okay? And B, got some decimals going on here, 4.47, getting a little specific there. All right, and so to prove it is a chord, again, a chord, you've got 2 points here, negative 3.6, somewhere up here, and that could be point A, we don't know yet. Point B, 4.7, I don't know, somewhere here. They would connect, maybe, we don't know, prove. Now to prove it's a chord, what I have to do is prove that these points are on the circle. So this comes back to example number 1 again. All right, so first off, point A. I'm going to substitute my x value of negative 3 and my y value of 6 into the equation of a circle. And what I need to have is it needs to total up to 45. All right, so I take my negative 3 and I square it. I take my 6 and I square it. And then let's see what I get. So negative 3 squared. Hey, man, we've already had that one. That's a 9. I take 6 and I square it. I get 36. And if I add those two together, 9 plus 36, I get 45. Point A then is on the line, or on the circle, sorry. Get so used to linear equations, right? All right, so point A is on the circle because it equals 45. When I substituted in x, figured out x squared plus y squared, it reaches up to 45, reaches out to 45, and so point A is on the line. All right, so for it to be a chord, B must also be on, the circle. B must be on the circle. All right, so I'm going to do the same thing for point B. All right, so I take my 5, which is my x value here, and I square it. All right, I also take my 4.47, a little specific there, and I square it. All right, and so, well, I know 5 squared is 25. 4.47, though, that's going to take some work. Let's see, so 4.47, I square it. And if I round to 2 decimal places, I get 20. Add those two together. It is 45. And so point B is on the line, or on the circle. Me and linear equations here, on the circle. All right. And so therefore, the line segment AB is a chord. Because both points are on the circle, but clearly, you look at our diagram here, they do not go through the center, which could make it the diameter of the circle. But it's not. It's only a chord, which means, again, that both points are on the circle, but yet do not go through the center. But again, I substituted into the equations of a circle to see if my r squared is the same as the equation of a circle, which in this case they both were, which means it's on, both points were on the circle. And because they're connected, it makes it a chord.